Hey y'all. So in this video, I do want to discuss a few things. Essentially, we're going to be graphing these quadratic formulas. And when we graph quadratic formulas, we need to be identifying the vertex, the axis of symmetry, the y-intercept, and any x-intercepts that we might have. Now, we're not guaranteed x-intercepts because if you've done some of these solving quadratic equations already, you've seen that you could get some imaginary numbers, the x values that have an I in them. And what that is we don't have any x-intercepts when that happens. And with our quadratic equations, if we do have x-intercepts, we can have one or we can have two. So we're going to discuss that in this video, along with finding the vertex two different ways. And we're going to be working with two different forms of our quadratic equations. So we have the general or standard form where it is in the form of ax squared plus bx plus c. And then we've got forms that are vertex form, and that's the ones that kind of look something along these lines, where you have the binomial squared plus a constant. And if you've already watched some of my previous videos where we solved quadratic equations by completing the square, essentially what we were doing was pretty much getting our quadratic equation into vertex form. But we are going to look at converting or writing our quadratic functions, equations into vertex form without having our equation set to 0. And just jumping right into this, because I'm pretty sure that didn't make a whole lot of sense if you haven't seen this once before. So just starting with number 2, they give me the equation y equals x squared minus 2x minus 5. Now, when we complete the square, our leading coefficient has to be 1. And ours in this case is. And so I'm going to write this y equals x squared minus 2x minus 5. So my leading coefficient is 1. Now, when we were solving quadratic equations and completing the square, we would have moved this -5 across the equal sign. But in this case, when we are getting our equation in vertex form, we're not going to move that across the equal sign. But what I am going to do is I'm going to move it over. I'm going to get it away from my x squared and my x term. So as we complete the square, we've got to complete the square to convert to vertex form. When we complete the square, I'm going to add to this half of that squared. So half of 2 is 1, and I'm going to square it. Now what I added to my equation is 1. I need to come over here and undo that. So I've got to add it, and I've got to take it away at the same time. Just coming off to the side or down to the bottom, just to show you what I'm talking about. If you've been solving quadratic equations by completing the square, essentially what's going on here is we would have had x squared minus 2x equals positive 5. We would have added 1 squared, and what I do to one side, I do to the other. But here in this particular case, when I added that 1 squared, I'm not doing anything on the other side of the equal sign. I'm doing everything on the same side. So what I add to my equation, I have to turn around and undo it because I don't need to change my equation. I need to keep it the same. And if you look at down here at the bottom where I'm solving for x and I've added 1 squared to one side, I need to add 1 to the other. If I were to move all of this back over here, I would have x squared minus 2x plus my 1 squared minus 5 minus 1 equals 0. So I would have exactly what I've got going on up here at the top. It's just right now what I've got going on at the top, I've got y equals y, where down here I'm saying y equals 0. So that's where we're slightly different from solving, where I'm not solving yet. I'm just simply rewriting my formula. I'm putting it in vertex form. Now moving forward from my vertex form, what I'm going to do is I'm going to factor this perfect square trinomial. And the way I factor that is I pull one of those x's down here, one of those 1's, and then I bring that minus down. And then I simplify this to be minus 6. And the whole idea, the reason why we want to get this in vertex form, well, the reason for the case of my college algebra class, the reason why we want to get this in vertex form is so that we can look at this and identify what our vertex is. When we're in vertex form, which is y equals x minus h squared plus k. The vertex is hk in that form. So here, our vertex is 1, -6. We take the opposite sign of what's on our x, but we take the actual sign of our y when we put it into our vertex. So instead of -1, I put it down as +1. In our -6, it actually goes in as -6. So our vertex here is 1, -6. Even though in this particular worksheet, they only asked us to put it in vertex form, we took it a step further and found our vertex, because where we're going with this is we want to graph these quadratic equations. And let's do that. Why not? So when we graph these quadratic equations, you're going to want to plot the vertex, the y-intercept, any x-intercepts we might have, as well as our axis of symmetry. So when we plot the vertex, we want to plot 1, -6, and our points are x, comma, y. So we go to the right 1 and down 6 to get our vertex way down here. Then we want to go and find our y-intercept. Now, since we've got our equation represented in 2 different forms, I've got it in this ax squared plus bx plus c. I can look at this and tell that my y-intercept is the point 0, -5. The way we find y-intercepts is we set x equal to 0 and solve for y. So when x equals 0, those two terms go away, and I'm left with just y equals -5. So my y-intercept is the point 0, negative 5. And now I want to get my x-intercepts. X-intercept is where we set y equal to 0 and solve for x. Now, when we're in this ax squared plus bx plus c form, we would need to see, can we factor this? And we can't. We would then resort to, do we use the quadratic formula, or do I go complete the square and solve it that way? Well, we already completed the square when we got it in vertex form, so why not work with that one? So when we want to find our x-intercepts, y equals 0, and we solve for x. So I'm going to add that 6 to both sides to get that 6 equals x minus 1 quantity squared. To get x by itself, we're going to square root both sides. And when we square root that, that is plus or minus the square root of 6. So we wind up with, let me get myself a little more room. I'm going over here. I've got plus or minus the square root of 6 equals x minus 1. And when I add that 1 to both sides, I get that x equals plus or minus square root of 6. That is x equals 1 plus square root of 6, and x equals 1 minus the square root of 6. Now we need to be able to get some points to plot, so we can type that in our calculator, 1 plus the square root of 6, to get that this one is approximately 3.4. And then we do 1 minus the square root of 6. And this one is x is approximately negative 1.4. So those x-intercepts, if we write them in coordinate form, 3.4 comma 0, negative 1.4 comma 0. So 2, 3, and somewhere right in, somewhere right in there, and then negative 1.4-ish somewhere in there. Now, I haven't discussed the axis of symmetry yet. The axis of symmetry is an imaginary line. It's just if you were to fold your parabola in half, because parabolas look something along those lines. If you would fold it, if you were to fold it in half, and if I can draw to scale, the crease that that parabola would make would be the axis of symmetry, and the two sides would mirror each other. So the axis of symmetry is a line that goes through, it's a vertical line that goes through the vertex. And that's handy to know when you're graphing your quadratic equation, because you can get another point on your graph. So if I've got my y-intercept here, the distance that I'm going to travel to my axis of symmetry, I can travel that same distance away from it and get another point on my graph. And so when this one's kind of hard to do on my paper here. I couldn't go through it. This is tough. Let me see if I can do a better job here. It's hard to draw on this. But you need to try to make a parabola shape when don't make it straight. That's super ugly, and I'm ashamed of myself, but I am still going to publish this. But do everything you can when you're graphing these to kind of have a curved shape that almost looks like a reindeer. Okay. So that was writing an equation, a quadratic equation in vertex form finding the vertex, finding the y-intercept, finding the x-intercepts, and putting that mess on a graph. Let's go down here and do one of these that hopefully will be a little bit cleaner. So just jumping over here to number 20. I want to put this on the graph. Now to graph these things, I need to identify the vertex, the axis of symmetry, the y-intercept, and any x-intercepts. So since this one is already in vertex form, I can see that my vertex is -2, -1. I take the opposite sign of what's in there for the x, but I take the actual sign of what's in there for my y. And when I plot that, that is -2, -1. And my axis of symmetry is the vertical line that goes through that vertex. So the axis of symmetry is x equals -2. X equals -2. Now to find my y-intercept, I set x equal to 0 and solve for y. So taking this f of x equals x plus 2 squared minus 1, I'm going to change my f of x to y, and then x equals 0, and we solve for y. So we get that y equals 2 squared is 4 minus 1, y equals 3. So my y-intercept is 0, 3. 0, 3. To find my x-intercepts, I set y equal to 0 and solve for x. I hate that I just erased that, all of it, but okay. So y equals 0 and solve for x. So I'm going to add 1 to both sides to get that 1 equals x plus 2 squared. To solve this, I square root both sides, and that is plus or minus the square root of 1. So plus or minus 1 equals x plus 2. And then I subtract 2 from both sides. I get that x equals -2 plus 1, and x equals -2 minus 1. So we get -1, -3. So my x-intercepts are -1, 0, -3, 0. Getting those points on my graph. Now I do want another point to put on my graph, and I'm going to use what I know about the axis of symmetry and a point on one side of my graph. So looking at my y-intercept here, I have to go 2 units to get to my axis of symmetry. So I'm going to go 2 units away from it to get a 5th point, so that I can, I don't know why I cannot. There we go. And there's our parabola. That one's a lot better than that first one I did. I hope this helps you with writing an equation in vertex form, identifying the vertex, the axis of symmetry, finding y-intercepts in either form, finding x-intercepts in either form, and getting our graphs on an XY coordinate plane. If you want to see any other videos, any other examples, please let me know. Y'all take care.